Hello and good afternoon friends, welcome to CEC EduSec live lecture. Dear friends, in this session today we are going to talk about plate tectonics. You might have heard about this term many a times, many of you have also read about it, but today we are going to make it very lively, that is through this EduSec lecture. We are going to disseminate or deliver you lots and lots of information what basically tectonic plates, that is plate tectonics are, what the major changes are caused by them on the earth due to them, as well as what effects does it plays on the flora and fauna. For this we have with us in our studios Dr. B.W. Pandey. He is basically associate professor in School of Geography, as well as I would like to tell you that he is basically going to deliver a lot on this topic. So first of all, I would like to welcome our guest, Dr. B.W. Pandey. Sir, welcome to the EduSec lecture.
Thank you very much. This is a plate tectonics theory. I'm going to discuss a very basic component of the plate tectonic theory, which will be immense use of the students community and other learned community to know about the components of the plate tectonics, its effect on the changes on the earth. Changes on the earth means changes in the lithosphere, changes in the crust, changes in the water, changes on the land, and proportionately the distribution of water resource, land resource, and its impact on the flora and fauna. Then different ages had different domain of the flora and fauna time to time. That all we'll discuss, but the basic we'll discuss first the plate tectonic. What is plate tectonic? Before describing the plate tectonics, the student must know what is a plate, what do you mean by plate. So plate are the solid rigid landmass floating on the viscous material called asthenosphere. The upper part of mantle and the crust. Say the crust, mantle and core are the three interior structure of the earth that you must have learned in the schools and colleges. That is also called sial, silicon aluminum in the crust called sial, silicon magnesium in the mantle called sima, and nickel and iron in the core, it's called Nephi. To discuss the plate tectonics, I'd like to mention here the entire crust, which is about 30 kilometer from the surface, it's 30 kilometer, and below crust is the solid, hard, high density mantle. Upper part of mantle, excuse me, upper part of mantle and the crust together form about 180 kilometer. Sorry.
You can have a glass of water, sir, because as we see that the temperature, or we can say that the season is changing and we are more likely to have a dry throat. Over to you, sir, again.
So 30 kilometer of the upper part of the surface, this crust, plus 150 kilometer of the mantle, together 180 kilometer, this is average. It may be somewhere about 50 kilometer and somewhere more than 200 kilometer, but overall on average 180 kilometer surface, which is hard, known as lithosphere. And this lithosphere is not one piece of land. Lithosphere is divided into 6 major and about 20 minor parts. These parts are floating above the asthenosphere, which is called plate. And movement of plates called plate tectonics. The interior of the earth, which is the crust mantle core, say about 0 to 35 kilometer average is the crust. It goes up to 2900 kilometers the mantle, and the interior 6371 kilometer is the core. Plate tectonics is the condition associated with upper part of the surface, upper part of the earth. 180 kilometer floating over the hot molten stage, viscous stage surface called asthenosphere. So that floating parts of the lithosphere divided into 6 major and about 20 minor parts altogether known as plates, and movement of plates known as plate tectonics. Movement of plates known as plate tectonics. So whenever the two plates collide, the plate which is high density subducted below, and the plate which is of low density is folded up. The plate which is folded up form the fold mountains, and the plate of high density will sink down, which is subducted, form trench, deeps, and different kinds of geomorphic landforms. There are 6 major plates known as Pacific plate, Eurasian plate, American plate that covers North America and South America together, Africa plate, Antarctica plate, and Indo-Australia plate. Apart from these 6 major, there are a number of about 22 minor plates. These minor plates, known as Nazca plate, Arabian plate, Philippine plate, Juan de Fuca plate, Scotia plate, Cocos plate, and other about 20 minor plates altogether. See on the map, the largest plate is Pacific plate. This is oceanic plate, entire Pacific plate in the ocean. Then second largest is the Eurasia plate. It comprises Europe and the Asia continent north of Himalayas, and part of the Arctic Ocean, Atlantic Ocean, and the Pacific Ocean. Third is American plate, comprising North America and South America continents, and almost half of the Western Atlantic Ocean. That form the American plate. Number 4, African plate. It comprises Africa continent and the surrounding oceans like in the Indian Ocean and the Atlantic Ocean. And number 5 is Antarctica plate that covers Antarctica continent and the surrounding southern oceans. And finally, number 6 is the Indo-Australia plate comprising India, Australia, and in between the Indian Ocean, and in the eastern part of Australia, part of the Pacific Ocean. These are major plates. Beyond the major plates, there are a number of minor plates which are also very large, like Nazca plate, Arabian plate, Philippines plate, Juan de Fuca plate, Scotia plate, Cocos plate, Caribbean plate. All these minor and the major plates, their movement called plate tectonics. movement are responsible for continental drift. Movements are responsible for the origin of the mid-oceanic ridge. Movements are responsible for the origin of volcanoes, origin of earthquake, formation of islands, and different kinds of hazards, disasters like tsunami occur basically when there is a subduction in the ocean, plate tectonics in the ocean. These plate movements are broadly classified into three types, that is known as divergence movement from divergence plate boundary, convergence movement when the two plates collide with each other, and third one is neither divergence nor convergence, is just sliding is called conservative plate margin. So there are three kinds of plate movements, and the plate movements, the consequences along the boundary of the plate called plate margins. So there are a lot of changes on the earth, change in the distribution of oceans and continents, change in the distribution of mountains, plateaus, plains, hills, change in the river system, change in the climate, change in the flora and fauna, all these are associated with these plate margins. Due to these plate margins, you must have heard the name of very famous paleoclimatic scientist called Alfred Wegener, who is popularly known for postulating the theory called continental drift theory. See, what is continental drift theory? If you see today, we prove on the scientific method. So it is the origin of the plate tectonic theory is based on theory of the continental drift of the Alfred Wegener. Due to convergence and due to divergence, plates are either moving towards each other or drifting away from each other. So these consequences resulting the continental drift, change on the climate. Climate change, the most important phenomena of the climate change is the latitudinal variation of the place, of the continents, of the country from time to time, from geographical scale. India, for example, see, 70 million years back, India was lying about 60 to 65 degrees south latitude. Today, 60-65 degrees south latitude means it was coincided with Antarctica continent. India had a subpolar climate. The kind of flora, we had the fossils of the flora, Glossopteris, which is a kind of cryophytes, a cold vegetation, like tundra vegetation, and India today is north of the equator, lying 8 degrees north of the equator. So from 60 degrees south latitude in the past to 8 degree north latitude today, the position, shifting the position of India, shifting the latitudinal changes on the geographical area of India is all because of plate tectonics. This is the main feature, and all this possible due to the divergence and the convergence of the plate margin. Divergence. Divergence takes place where the distribution of the lithosphere is very less, where asthenosphere dominates. This condition found mainly in the ocean. lithosphere in the ocean is very thin, and asthenosphere is very extensive in the ocean. Therefore, more radioactive material, hot molten magma, lava, easily break the lithosphere of the ocean, and due to the heat passed from the magma to the lithosphere, the rock, the lithosphere gets heated and expand. Due to expanding, there is a divergence in the ocean bed, that is called divergence plate boundary. See in the map, the figure, the figure shows there is a movement of lava, flow of lava, and this flow of lava, they transferring the temperature, and the thin part of the lithosphere is melted down, spreading out, going out. This condition only occur in the ocean. Therefore, almost all the divergence boundaries in the world, on the earth, found in the ocean only. Second type of movement is the convergence. Convergence boundary are three types. Convergence are three types. Convergence between ocean and continental plates, convergence between oceanic and oceanic plates, convergence between oceanic and continental plate. So there are in three types of convergence boundaries, and this is very interesting that convergence boundaries have a lot of geomorphic landforms, lot of geographical evidences, lot of consequences. I will go to detail. Say first convergence, oceanic and continental. Second convergence, oceanic and oceanic. And third convergence is continental and continental. Here I'd like to elaborate what are the causes for these the convergences and what are their consequences. First of all, we'll discuss the oceanic and continental convergence. Oceanic and continental convergence means when the two plates, one plate having ocean, other plate having continent, when the two plates collide, definitely the plate which is oceanic having high density as compared the plate of continental. When the oceanic and continental plate converge, oceanic plate because of high density subducted below. Due to convergence, the thick high density oceanic plate is subducted and the light density plate of the continent is folded up. So there are a number of examples you can find in the map about oceanic and continental convergence. Most important evidence, you find the Nazca plate, that is a part of the Pacific plate, Nazca plate converging with South America plate. Similarly, Cocos plate, Juan de Fuca plates, which are the part of Pacific plate, oceanic plate, converging with North America plate. So all the way from South America to North America, there is convergence of the oceanic plate and the continental plate. Let's see what are the consequences. Oceanic plate, because of high density, it's broken and subducted below the light density continental plate. But as soon as the two plates collide, the light plate, continental plate, because of light material, is folded up, and due to folding, it forms fold mountains like Andes Mountain, Rocky Mountains. Andes Mountains, Rocky Mountains are formed due to convergence of the oceanic and continental plate. Then, because the movement plate is continuous, then oceanic plate is broken up. Due to breaking up, it forms a narrow dip that is parallel to the mountain. This is known as trench. So you find folded mountain on the margin of the continents and trench in the margin of the ocean is almost parallel. We'll find the Peru-Chile trench is the longest trench in the world. Appalachian Mountains are the longest mountain in the world. Then trench parallel to the North America continent and the Rockies Mountains, Alaska Mountains, a chain of the fold mountains along the Pacific Ocean. Finally, due to subduction of the oceanic plate below the continental plate, it moves down. Due to subduction, there is a collision. Due to rubbing the two plates, temperature goes high. Temperature rises even beyond 3000 degrees Celsius. Due to rising of the temperature, the crustal material melt down and forms lava. That lava moves up and it breaks the fold mountains, and that develops a chain of the volcanoes, chain of the volcanic mountains above the fold mountains, such as Cotopaxi, Chimborazo, Mount Hula, Mount Aconcagua, Mount South Sisters, Mount Rainier, Mount Hood. All these volcanic peaks are developed, formed above the fold mountains due to convergence of the oceanic plate and continental plate. Second convergence is the convergence of the oceanic plate with oceanic plate. Convergence of the oceanic plate with oceanic plate. This is very interesting. When both the plates are oceanic, means both the plates, the lithosphere is thin. It happens in the ocean. The plate which is high density subducted below, but here you must keep in mind that because both the plates are oceanic plate, therefore there is no folding, no fold mountains formed in this convergence, because both the plates are oceanic. Therefore, out of the two plates, the plate which is heavy is subducted, broken, and form trench. Trench. Formation of deep trench, wide trench are very common in this kind of convergence, oceanic and oceanic convergence. For example, in the eastern part of the Asia continent, if you see in the map, you will find a series of the trench, like Mindanao Trench, called Mariana Trench, Philippines Trench, Japan Trench, Aleutian Trench. All these trenches are formed in the western part of Pacific Ocean due to convergence of the oceanic and oceanic plate. Then, after the convergence, the subduction, which form the trench without fold mountains. Then, due to subduction, tectonic process continue. The lithosphere subducted below one plate to the other plate. Consequently, due to rubbing, temperature rises and the crustal part of the lithosphere melted down and forms lava. That lava ultimately get deposited, keep on rising. Now it depends the amount of lava. If the lava is continue, then it may rise above the water and form a volcano, form a island. And if lava is less, is remain below the water, they form the seamounts, underwater volcano. Later on, parallel to the trenches, there are chain of the islands. So these islands are almost parallel, and these islands, the bunch of the islands, the group of the islands altogether known as archipelago, like Japan archipelago, Philippines archipelago, Caribbean archipelago. And here I'd like to explain you that if archipelagos, chain of islands, are in the arc shape parallel to the continent, then this kind of archipelago known as festoons. So Japan is the best example of the festoons in the world. It is arc shape archipelago parallel to the continent coast. Then the third one is the convergence between continental plate with continental plate. So now, continental plate converging with the continental plate means both the plates made of light material. Both the plates have very deep root of the lithosphere. Therefore, this is another very, very interesting description I would like to give you, that when both the plates are continental, for example, Indian plate and the Laurasian plate. Laurasian plate also called as Eurasian plate. So Indian plate and the Eurasian plate, when they collided, both the plates are light material, both the plates are continental, so massive bending, massive folding. Due to massive folding, it forms big size of mountains. Very big size of mountains, fold mountains like Himalayas. Sorry. So fold mountains like Himalayas. Number of movements, number of tectonic pushes form a number of chains. That's why you will find a number of chain in the Himalayan mountain systems, which called Greater Himalaya, then Lesser Himalaya, then Upper Shivalik, Lower Shivalik, because differences in the time of tectonic forces, tectonic movements. So continental and continental convergence forms big size of mountains. When the mountains are parallel, there are three chains, the parallel altogether known as Cordillera. So Himalayas are Cordillera, having Himadri Himalaya, then Middle Himalaya called Himachal Himalaya, and the Shivaliks are foothills. Three parallel mountain chains all together known as cordillera. Cordillera are formed. But what is missing here? When I discussed the oceanic plate with oceanic plate with continental plate, I discussed the volcanoes, volcanism. But here, when both the plates are continental plate, there is lithospheric root, very deep lithosphere and very less asthenosphere. Therefore, due to collision, due to rubbing of the light material, having less temperature, therefore melting of magma, melting of lava is very less. Hence, no volcanic peaks, no volcanoes are found on the fold mountains if they are formed due to the convergence of continental and continental plates. You will never find a volcano on Himalayas because it is formed due to convergence of the continental and continental plates. So, three types of convergence boundaries we discussed: oceanic and continental, oceanic and oceanic, continental and continental. So, divergence is only one type that happen only in the ocean, but convergence are three types. It could be in the ocean, could be on the continent, could be on the margin. So, first, divergence plate boundary, second, convergence plate boundaries, and third, transform boundaries, also called conservative boundaries. Transform boundaries means when the two plates neither diverging nor converging, rather simply sliding, then due to sliding there is no effect of divergence and convergence, therefore there is no subduction, only it forms fault. The kind of faults developed along the conservative plate boundaries called transform fault. Due to transform fault, this boundary, also known as transform boundary, or conservative boundaries. Friends, there are three types of plate margins, plate boundaries we have discussed. Then these plate boundaries are associated with landforms, different kinds of landforms. For your information, I would like to revise these landforms. You can read on the screen that landforms of the divergence plate margins are mid-oceanic ridge, and if it is very wide, they call mid-oceanic rise, like East Pacific have rise, Atlantic have ridge, and form lower size of tableland due to deposition of lava, then called submarine plateaus, and if it appears above the water, then called islands. Second, you can see a number of ridge and rise. The East Pacific are rise, Mid-Atlantic are ridge. Mid-Atlantic ridge, 14,400 kilometer, is the longest oceanic ridge in the world. Similarly, over 10,000 kilometer long of the East Pacific rise is the largest and the longest rise in the world. Then the landforms developed along the convergence boundaries. Convergence with oceanic and continental form fold mountains, trench and deeps. Trench and deeps, where it is narrow and long is called trench, and when it is wide and open, then called deeps. So trenches are found in the East Pacific and deeps are found largely in the West Pacific. And then volcanic mountains. The convergence forming the trench, deeps islands, and then the convergence between oceanic and continental plates forms fold mountains. Sorry. Trench volcanic mountains along the continents. The oceanic and oceanic plates develop trench, deeps, volcanic islands, volcanic mountains, volcanic arc, volcanic archipelago, and volcanic festoons. This is the distribution of volcanic islands, ridges, rises in the world. We'll discuss this later in detail. Then continental and continental convergence form fold mountains. As I told you, if the fold mountains are formed due to convergence of continental and continental plates, then there is no volcanic extrusion. It's all volcanic intrusion. Therefore, the two plates joint called suture zones. So suture zones, for your information, I'd like to explain, the suture zones are found only if both plates are continental. Then lot of intrusive landforms like batholith, laccolith, lopolith, phycolith, xenolith, sill, and dikes. These are different kinds of intrusive landforms, and when the lava could not appear above the surface, remain inside, get cooled, hard, become hard surface, then it's called intrusive volcano or intrusive volcanic landforms. I'd like to explain, this is suture zone, see on the map, the suture zone. Suture zone, very common suture zone in the world, lies along the boundary of Indian plate and the Eurasian plate. That Sangpo suture zone, Indus suture zone, Satluj suture zone. So through these faults, through these suture zones, today we have developed river systems. So the suture zones are also known with the name of the drainage, like Sangpo Satluj suture zone, Indo-Sangpo suture zone. So these rivers are draining through these suture zones. Then intrusive volcanoes, when it is form a dome shape volcano inside, then the dome shape big size of deposition called batholiths. These batholiths, due to tectonic forces, sometimes it appears above the earth, above the surface, form the big size of plateau, such as this. The Ranchi Plateau is one of the examples of batholith plateau. Then the landforms like laccolith, lopolith, phycolith, xenolith, sill, and dike, these are also associated with the intrusive landforms. So when concave shape lava deposit inside the surface, called laccolith, and if it is concave shape, then form lopolith. If it deposits along the anticlines and synclines of the bends, it's not a regular, it's irregular deposition along the anticlines and synclines, then it is called phycolith. And finally, when it is horizontal deposits known as sill, and the vertical deposits called as dike. This is the best example of the dike in the world. So any horizontal deposits are sill and the vertical deposits are dike. These dikes are very hard. A number of dikes you will find over the western part of US, and whenever the volcanoes become dead volcano, the cone of the volcano, in the crater in the middle of the volcano, the hard lava deposit also is vertical, known as dike. Finally, because plate tectonics associated with volcanism, either extrusive volcanoes or intrusive volcanoes. So we have discussed the intrusive volcanoes, but there are chain of the extrusive volcanoes, which is the part of your curriculum, which is affecting the global climate. And these volcanic realms are divided into three parts, known as circum-Pacific belt or ring of fire, mid-Atlantic volcanic realm, and mid-continental volcanic realm. Number one, circum-Pacific ring or ring of fire. Almost 80% of the volcanoes in the world, active volcanoes in the world, occur along the ring of fire. This is surrounding the Pacific Ocean, therefore it is also called as circum-Pacific belt. When you take the photograph of the Earth from the space, the active volcanoes appears like a ring. Therefore, it is known as ring of fire. See, Pacific Ocean, the east margin of the Pacific Ocean having convergence of oceanic and continental plate, and the west margin of the Pacific Ocean having convergence of oceanic and oceanic plate. Here you have to examine that along the east part of Pacific Ocean, there is no volcanoes in the ocean, there is no islands. All the islands, festoons, archipelagos lying in the western part of Pacific Ocean because of convergence of oceanic and oceanic plates. So eastern margin of Pacific, volcanoes on the continent, above the fold mountains, above the Andes mountains, above the Rocky mountains, and volcanoes of the West Pacific in the ocean, in the Aleutian Islands, Kuril Islands, Japan Islands, Philippines Islands, Tonga, Kermadec Islands, and New Zealand Islands. So, ring of fire, circum-Pacific belt is number one. Number two is mid-Atlantic. Mid-Atlantic realm, volcanic realm, begins from Hekla, Lipari of the Iceland and moves parallel to the mid-oceanic ridge, and because it is found in the middle of the Atlantic, so-called mid-Atlantic volcanic realm, but it divides in two parts. One moves towards the Caribbean Sea, called Caribbean branch of the mid-Atlantic volcanoes, and other one enters in Mediterranean Sea. There form the Naples, Vesuvius, different volcanoes in the Mediterranean Sea, and the third one moves in the southern hemisphere. Third one, so the mid-Atlantic, circum-Pacific belt, and the third realm is mid-continental. So mid-continental found on the continents. It begins from Africa continent, Mount Kilimanjaro, Mount Kenya, Mount Rostas, and it moves parallel to the Red Sea. It enters in the western part of Asia continent, passing through Sinai Peninsula, where Mount Catherine volcano. Then it enters in Anatolia. Then passing through Iran, it becomes intrusive, passing through Himalaya, passing through Arachneoma, then it reappears in Andaman Nicobar Islands, through Andaman Nicobar, Sumatra, Java islands of Indonesia, it joined the CIRCUM Pacific belt. Friends, these volcanic realms are also the three seismic zones, seismic belts. So distribution of volcanoes in the world and distribution of earthquake in the world, they are common, because anywhere if there is an eruption of volcano, automatically there will be earthquake. If there is convergence of the plates, consequently there will be earthquake, there will be tsunamis. So plate tectonics is also important to understand the distribution of volcanoes, distribution of earthquakes, distribution of disasters, and finally the plate tectonics is a common discussion among all the earth sciences, because it is the root behind the distribution of oceans, continents, hydrosphere, lithosphere, biosphere, cryosphere. All components depends on the plate tectonics and its mechanism. Finally, thank you so much.
With this note, thank you, sir. Thank you so very much for delivering such a nice lecture and making us aware of the various reasons behind the tectonic plates. Now the question arises, as you yourself mentioned in the lecture, about the various tectonic plates, the name given to the various tectonic plates, that is the plate tectonics. My question is here that does if we talk about the plate tectonics, they are different in different regions?
It depends on the plates. Suppose if it is oceanic plate, then the consequences will be different than the continental plate. If the plate tectonics taking place, say the Indian plate and the Eurasian plate, there will be earthquake, no doubt, but no tsunami. But if there is a convergence between oceanic and oceanic plate, like western part of the Pacific Ocean, with the Japan, with Philippines, with Indonesia, if there is a convergence, then definitely there will be tsunami. So any subduction the bottom of the ocean means bring the tsunami. This is the reason that maximum tsunamis occur along the Japan, along the Philippines, Korea, and the Indonesian islands. So definitely it varies, it depends on what kind of plate the plate tectonics taking place, subduction is taking place.
You told us about the major climate changes it brings. So if we want to say one particular name, that is if we talk about the climate change, what kind of climate change basically it brings?
Due to divergence plate, the continent keep on changing the latitudinal position. For example, see in the world map, the southern part of the Indian Ocean, the Antarctica continent. So 60 degrees south latitude is extremely cold climate. 70 million years back, India was on 60 degrees south latitude. And due to divergence plate boundary, the Indian plate keep on drifting towards north. Finally, when Indian plate was 60 degrees south latitude, it was cold climate, tundra climate. When it moves towards 30 to 50 latitude, it becomes subtropical, temperate climate. Then it moves towards 10 degree latitude, it becomes tropical. Then it becomes on the equator, become equatorial climate, and now cross the equator and move towards north. See, even India had experienced a number of climate changes on the land due to plate tectonics, due to drift of the continents.
That is, when we talk about the climate change of a particular country, we can think that it may be due to the plate tectonics of the various countries all along.
Yes.
It is the global climate change, we could say that.
Yeah.
So you mentioned the terms such as plate boundaries or plate margins. We would like you to tell us in short what basically these are.
because the plates, they are floating above the asthenosphere, but they are joined with each other. So whenever the plate moves, they rub each other. So that end of the plate called margin. So end of the table called margin. So end of the plate called margin. So what kind of margin is? If the margin in the ocean, there will be oceanic plate margin. And if the margin on the continent, we'll call continental plate margin. So the kind of landforms, kind of movement, kind of changes depends on the plate margin, because if it is the oceanic plate margin, there will be very thin lithosphere, and if it is continental plate margin, will be very thick lithosphere. So the changes will be different. Therefore, it is classified as plate boundaries or plate margins. So oceanic plate margins, continental plate margins, like that.
As you yourself talked about that whether these plates either they drift towards each other or they tend to move away from each other. So in both the cases, does they produce different effects?
Yes. Whenever the two plates moving away, called divergence. So this divergence largely occur in the ocean, because in the ocean lithosphere is very thin. More is the asthenosphere. There is more hot molten temperature, more high temperature, more radioactive material, so it's easy to break, and the oceanic plate keep on expanding. That is popularly known as sea floor spreading, because sea floor start spreading. So this happens in the ocean. And the second type, when the two plates move closer to each other, that is called convergence. So convergence can take place anywhere. It may be within the ocean, called oceanic and oceanic plate, maybe ocean and a continent, called ocean and continental plate, and maybe on the continent, so both plates are continent, called continental plates. So it depends where, at which place the divergence, convergence taking place.
So what kind of effects, basically, if we talk about, when we talk about, for example, the earthquakes or the volcanoes, these are because of the friction between the two plates?
Because of rubbing, because of the collision between the two plates. So earthquake is common. So any kind of plate, anywhere, if there is a collision taking place, definitely there will be earthquake. But along with the earthquake, other phenomena are volcanoes and tsunami. To have volcanoes, it is necessary the plate margins would be either in the ocean or ocean and continent boundary. If both the boundaries are continental, there will be no volcano. But definitely there will be earthquake.
Definitely, as Dr. B.W. Pandey has laid various examples how the earthquakes or the volcanoes occur and how the tectonic plates plays important part in their occurrence. Over to you, sir. Again, you were explaining the examples. What about the cyclones, sir? Does the cyclones have any connectivity with the plate tectonics?
No, cyclones are different phenomena. Cyclones are atmospheric phenomena, hydrological phenomena. Yeah.
Okay. Now, you have also used the term fold mountains. What are the fold mountains?
So fold mountains, whenever the plate margins, plate made of light material, means if it is continental plate margin, then if the convergence taking place, so margin of the continent is folded up, called fold mountains, like Rocky Mountains, Andes Mountains. These are example of oceanic and continental convergence. And other example, when both the plates are continental, then massive building takes place. Massive folding takes place, means kind of Himalayas, big size of mountains like Himalayas, and number of chain of the mountains. So greater Himalaya, middle Himalaya, Shivaliks, foothills, so number of chains of the mountain form, because both the plates are continental. So because mountains form due to folding of the crust, therefore these are called fold mountains.
So we could say that anything which happens inside the earth crust or inside the earth gives or produces the adverse effect on the lives on the earth. So what do you like to say about the flora and fauna or the environment of the earth? How adversely it is affected or not affected?
Yes, plate tectonics have a big impact on the ecosystem, on the flora and fauna. And as we discussed this, that there is also a large scale climatic change due to plate tectonics. So due to climate change, flora and fauna adopt a particular climatic condition, say temperature, rainfall. Therefore, the kind of species of the flora and fauna found in a particular climate known as biomes. So biomes keep on changing due to change in the climate. Drifting of the continents, shifting of the continents bring climate change. That have great impact on flora and fauna. You must have heard during Triassic period there were lives like Listosaurus, Mesosaurus, Sinogranthus. But when come Jurassic period, they become dinosaurs. And in the Cretaceous, due to plate tectonics, due to movement of plate, in the Cretaceous, the climate change, and all the dinosaurs extinct, disappeared. Similarly, set of the forest, set of the lives, they're largely affected by the movements of plates and plate tectonics. Also, different kinds of disaster, say folding, faulting, bending, volcanism, lava, also destroy the basic biosystem at any place. Then a new biosystem develops, gradually it adopts. So there is a large scale, massive impact of plate tectonics on the flora and fauna on the earth.
With this note, thank you, sir. Thank you so very much. You have made very important and we can say that the examples which sometimes we do not able to get inside the classrooms, we got all those examples here. Thank you, sir. Thank you so very much. And I would like to tell you all that Dr. B.W. Pandey would be again with us, and we would be coming with a very new topic, and I hope that tomorrow's session would be as productive as it was today. Thank you, sir. Thank you so very much.